Hello, Cappuccino. Here is part A from problem number 7. So here we're going to be using Euler's method to approximate the value of y when x is equal to 1.3, given the rate of change, dy dx is equal to x times e to the y. So I'm first going to do it with a table, and then I will do it with the graphing calculator. So what we're going to do is we're going to make a table with x values and y values, and our first x value is going to be 1, and our first y value is going to be 0.3. We were told our step value is going to be 0.1. So here's what happens. So first of all, this equation is in your formula packet. So if you look in your formula packet, my glasses so I can read the formula packet. In the formula packet, we have Euler's method right here. And it says y sub n plus 1 is equal to y sub n. So what does that mean? It means the next y value is equal to the prior y value plus h, that's the steps we're going to be taking. We're going to be taking little steps, times the function of x sub n, y sub n. So this is referring to our derivative, our dy dx. So this is the rate of change. So I'm not quite sure why they write it with the function notation, but this is going to be our rate of change, dy dx. And it is going to be in the form of a function of x and y. So that's why we're using the Euler's method, because it is a differential equation of x and y. And we can use this when we can't actually solve the derivative directly. Okay, then this part over here, it says x sub n plus 1 is equal to x sub n plus h. So what is this meaning? This means to get the next x, you take the previous x and you add the step value to it. Okay, so that's what we've got here in my table. I took these straight from the formula packet. My x value is going to go in my first column. So my x sub n is equal to the previous x plus the step value. So we said the step value is 0.1. So it's going to be the previous x value plus 0.1. So if I open that up, you can see the first x value is 1. And then we're going to add 0.1 over and over again. So we're going to step our way up because we're looking for when x is 1.3. Okay, so there's our x values. Now, to get our y values, well, we're given the first y value, 0.3. Now, to get the next y value, to get the next y value, it's going to be the previous y value, that's this, 0.3, plus h, and h is 0.1, times, this is going to be the derivative, and we're going to be substituting in x sub n and x sub y, which means the previous x and y value. Okay, so here it is. So to get the new y value, we're going to take the previous y value plus the step value times, I'm going to use my derivative to get my rate of change. How fast is the y value changing? And I've substituted in, see where the x is? I substituted in the previous x. Then it's times e to the y, so times e to the previous y. Then if I multiply that out, if I put that in my calculator, let's see if I have that here still. Here it is. If I put that in my calculator, 0.3 plus 0.1 times 1 e to the 0.3, I get 0.435. All right, so now I have a new y value. So this is now my y sub n. So for the next step, I'm going to start with this. Okay, so I'm going to start with where am I on the graph? I'm at 0.435. And what am I going to do? I'm going to add 1/10 of the rate of change. So the rate of change, it's going to be the h value, here's my h value, times x. Well, what was x? Remember, it's the previous x value. Here's the previous x value. So that's why this is 1.1, because it's the previous x value, times e to the 0.435. Well, why 0.435? Why not 0.3? Because it's the previous y value. Okay, so every single time you do this, these numbers are changing. Okay, these are actual variables. They're actually changing every single time. And if I multiply that out, I get 0.605. So now for my last step, because I'm going to end up where I wanted, which is x is equal to 1.3, I'm going to take the previous y value, 0.605, plus the step value times the x, the previous x, okay, there's the previous x, times e to the previous y. There's the previous y. All right, so here in this equation, when it says the x and the y, you have to use the previous x and the previous y to get the next one. So there's our answer, 0.825. So when x is 1.3, what is y? It's 0.825. And you can get that on the graphing calculator. As you can see right here, here's each of my steps. Notice when I wrote my answers down in my table, I rounded them off to 3 significant figures. And I did also round them off to 3 significant figures when I made them the exponent. I probably should have selected the whole number, but I didn't, and you know, it's okay. I got this answer. And this ends up being pretty close to what you get when you do it on the calculator. All right, so let's do Euler's method on the calculator. So first of all, when you do this on the calculator, there's going to be another column. You'll find that when we do this on the calculator, you're going to end up with another column called n, which is the step number. So this is step 1 or 0. I'll call it 1. This is step 2. This is step 3. This is step 4. And so these are all integers, okay? Just saying, you know, how many iterations, how many times did we run through the formula? So you could also start with 0. You could say this is step 0, this is step 1, this is step 2, this is step 3. And it really doesn't matter. So I'll show you how that shows up on the calculator. All right, so to set up the calculator, make sure you first check the mode. And here where it says function, you need to make sure you have the SEQ selected. Because once you have the SEQ selected, you're then going to hit y equals, the y equals button. And here is where you can enter in all of your parameters for the Euler's method estimation. This is where you're going to put in all your information. All right, so how do we put the information in? So different calculators have different options here. So if yours looks a little bit different, you just figure it out, okay? Play around with it until you get the right answer. So first of all, I figured out n minimum. That's just telling me the step number, the minimum step number. So it didn't seem to matter if I started with 0 or if I started with 1. Didn't seem to matter. So here I have it starting at 1. And then u sub n is x, okay? So u sub n is my x. So this column right here, these numbers, this is my u sub n. So what is my u sub n? Well, it's the previous u, wait, why did I say u sub n? What is my x value? It's the previous x value plus 0.1. That's what this is saying. So here on my calculator, I wrote this down. I can use n minimum as 1 or 0. Doesn't really matter. It's just these step numbers here. So for u sub n, this means, God, I keep saying it, u of n, this is your x value. What is your x value equal to? It's equal to the previous x value. See the n minus 1? It's equal to the previous x value plus 0.1, which is our step number, which is our h, you know, our step size that we're taking. Okay, so that's what you are putting in. That represents your x. Now, what is our starting x value? Our starting x value is 1. So you can see on my calculator, it says u of n minimum, and then I put it in. Other people, it says u of 1. Okay, and some of you I know you also have u of 2. I don't know what that's about, so just leave that blank. Okay, you don't need to put anything there. So again, if you have slightly different options on your calculator, play around with it until you get it right. See what happens, because I don't know. All right, or do some more research. But I find playing around with it, you can usually figure it out. Okay, so then next comes y. Y, okay, so this was our x. So here's our x. Now our y is going to be v of n. Our y is going to be v of n. So how do we get y? Well, how did we get it here? We took the previous y value. Okay, here, you don't see what I'm pointing at. We took the previous y value, so that's v of n minus 1, plus 0.1, that's our step, times, and now I need to enter in my differential equation. Okay, so my differential equation, my dy dx, which is equal to x e to the y. I need to rewrite this using these guys, u of n minus 1 and v of n minus 1. So that's what I did here. So x, remember we have to use the previous x. So the previous x is u of n minus 1 times e to the y. And remember, this was the previous y. Okay, if you look at what we did in the table, it's the previous y. So how do I get the previous y? V of n minus 1. And then what was our starting value? So our starting value for v is 0.3. So you see on my calculator, it says v of n minimum, but yours might say, maybe it says v of 1, whatever yours says. You got to get that starting y value in there. So we need to have the starting x value, the starting y value, and we need to have our equation how we calculate the next y value, which is directly parallel to what we do here. The big difference is that this is v of n minus 1 is our previous y. This is our h. And then here is our dy dx that's been written in terms of u of n minus 1 and v of n minus 1. Okay, so this has been written, this whole thing that I did in the table has been written in terms of u and v. So the 1.2, that was my x, so that would be u, and it was the previous x. And then it's times e to the power of the previous y. So that's why it's v, because it's y, of n minus 1, because it's the previous y. And there it is. And our h value, of course, for this particular problem was 0.1. All right. And then when you do that, you get, you hit to find your answer, you have to go second table. And then it'll bring up the table, and then you look for your x value that you want. I wanted 1.3, and if I go over, I see I get 0.825. So there it is. So notice this says 0.82466, and when I did it on here, I got 0.82475. So this ended up being a little bit different when I did it with the table, because notice I did not keep all of my digits when I did the exponent. But I bet if I had kept all my digits in here, I would have gotten closer to the value that I found on the table here of 0.825. But notice they both round off to the same thing when I do three significant figures. All right, so that was how to do Euler's method using the graphing calculator and doing the table. And there you have it. So yeah, so my answer here, y is equal to 0.825. That's it.